Hey there, this is Seth Juarez from Channel 9 back at PyData Seattle, but we're actually in Redmond.
Yes.
So, and I have a special guest here today, by the way. If you do want to participate, you can use the @PyData Seattle, I think, to ask questions of the speakers. So make sure you do that. They want your questions. In fact, they don't differentiate between questions from the audience or questions from this audience. And so feel free to take part. So why don't you introduce yourself, my friend?
Yeah, my name is Andy Terrel. I'm president of NumFocus, and so I help the NumFocus Foundation kind of lead the board and help the staff kind of do their jobs and so on.
So let's start with a basic question, because I've heard of NumFocus, but what is NumFocus and why is it important?
Yeah, so we're a nonprofit that's our kind of primary goal is to help projects sustain. I think a lot of open source code is either gathered around, for example, universities might be gathered around a scientific problem, or at a company might be around a business goal or something like that. And when we kind of came together in about 2011, there was a bunch of people who were like working on projects. We were like, well, how do we sustain our projects?
Right.
And that was a critical need, and so we're really focused on how do we help projects sustain, add diversity to the members, their governance, and kind of grow and help people solve problems.
So just to give you a little bit of my background, like I was using Python like 2.7, right, when I was doing research. How has the ecosystem changed since then to now that requires NumFocus?
Yeah, so I think over the last few years, one thing that's definitely changed is like data science has kind of come and taken over as a primary use case. And the tools have gotten better and better. And one aspect of that is, like, for example, our community has been in data science for many, many more years. And there's a lot of tools that are catching up to R. And so there's some tools that are catching up to some of the big data systems that are written in Java. And so right now, I think some of the interesting things, which is like data formats. For example, you have the Arrow project that Mess McKinney, who wrote Pandas, makes it easier to use big data sources that kind of maybe produced in a big Java system. Or you have also something that's come up with us is we have, I think, 2 projects now that are doing probabilistic programming, and I think there's another one is being added. And so it's this whole new paradigm of programming. For example, Stan is a project that I think it's written in C++ on the hood, but it has like a Python interface and several other interfaces. But the probabilistic programming is being used by companies all over to do a lot more forecasting. Something like 5 years ago you didn't really even talk about, but we've had PyMC, and now there's PyMC3. And so that probabilistic programming piece is pretty big. Of course, scikit-learn, I think that it's hard to pin down when it became popular and when it was started, but yeah, it's grown, and like now I think it's become so popular that people have like commercial implementations, and they have integration with everything. And so like if you don't have a scikit-learn interface now, it's like, well, where are you in today? I mean, I think that's become like a nicer interface that allows people to do all sorts of data science without really having to learn the entire ecosystem.
Right.
And that's carried on, so now TensorFlow is a big deal, and you have Keras, it's kind of like the scikit-learn of deep learning. And so all the tools to get to use GPUs, such as like the Numba, for example, and other like Pandas data frame and things like that are now on the GPU and are on different types of streaming processors that then link to some of these cooler projects like TensorFlow and deep learning. So I think like the ecosystem is, Python I think has grown up as like a respectable data science language, and now there's like a lot of data engineers are trying to integrate it in pretty much everything they do.
So why do you think Python has become, like, the reason why I used it is because it was super, like, I just did array things, and then I just like do a tick, times this, a transpose, it would just happen magically. But why has Python become sort of one of these perennial data science languages along with R and maybe Julia?
I think that one is that it does have that capability to do some operator overloading, so it's very easy to write mathematically. The other is that it's very easy to embed. It's very easy to put it in in a Java process, or on a big node, or on a small node. I mean, there's like micro versions of it. But also, people have kind of realized that its speed of development is so fast that you really want to capture that, and you can capture ideas and iterate quickly, but it also works in those bigger in production environments, whereas there's challenges getting some of the more closed off like a kind of enterprise solutions in that, like if you're trying to, not to be bad or anything, but like for example, we're trying to pull out a SaaS type thing, it's like there's limits to how much, based on your budget and what you can put in, whereas Python, it can integrate all the way up to very, very large clusters, which we've seen in numerous cases.
Let's talk about Python, because Python, as far as computing large things, because my understanding was that it's a dynamic language. When I used it, everything was happening on my CPU. I didn't know how to offload things to GPU. I didn't know how to do distributed computation with Python. Why don't you discuss a little bit about how Python is doing that now?
Yeah, so I mean, Python usually works with some other computational engine. For example, there's the PySpark ecosystem. So Spark is a big distributed system written in Scala. It kind of works on the Hadoop stack, and then they use Python. They just embed your Python code into the running Spark jobs. And so there's some memory transfer back and forth on each node, but overall, so it's not, Python's not managing every bit of the data, but it is managing the interaction that you might write as a data scientist. And there's the same thing for GPUs, or the GPU analytics type pieces, where it looks very similar to what we would write normally as a pandas data frame, like the GPU data frame, which is kind of a new thing come out. And you just compilers and technologies that are like CUDA that already knows how to use the GPU just kind of takes it and writes it to that system. And so you don't have to know. I mean, I remember the old days of GPU computing where you actually wrote shaders and things to do your matrix computation, but now it's like so automatic that you can write Python and runs on those streaming processors. And I think there's a lot of projects that are trying to get it into different places, from FPGAs to embedded devices as well. I guess I mentioned that one. So
it automatically moves the data frames, for example, over to the GPU?
Yeah, but it's just like what your when you do your AX plus B on a matrix, like it was calling, the old days it was NumPy's calling Fortran, right?
Yes.
Now we're calling CUDA and maybe some other lower level libraries, but we also can turn it into like LLVM, which is a low level vector machines language, and then that can be rendered as PTX code. That's the actual assembly on the GPU, and so we've come a lot farther in doing those sorts of techniques. And we mentioned before we talked, like Julia is another language based completely on this LLVM idea, right? And so Python has been able to uptake that and embed in a lot more places. But you still need those big data systems like the Parquets and the big Hadoop clusters and that sort of thing. Those systems just gotten a lot better at talking to Python because it's become so important in the data science toolbox.
And it's cool that because for some reason, I don't know why I didn't do this, but there's two separate notions. There's separate of a language, Python, and there's a separate notion of the runtime, Python.
Sure.
And what you're saying is that with these new implementations of the runtime, that some are GPU based, others are, for example, Spark based, and there may be some other based that'll do distributed computation a lot better.
Right, and sometimes, usually it's not the full like C Python runtime that's implemented. It's usually just some small part that you're gonna link off to and have that run. And so it's often constrained to what you can do, but Python is such a great embeddable language that we do a lot of really cool stuff with it.
So let's talk about NumFocus and how you actually support projects. And then I was hoping, because we have about 15 minutes, and then we'll talk about some of the projects that you do support. So let's start with, let's just say there's a project out there that's becoming widely known. What is something that you do to support them? How do you support them?
Yeah, so our primary mission is to help those projects that need fiscal and legal support. So I think a lot of projects, if you're just like 2 or 3 people who work on something on the side, you don't really need to have a legal entity, right? It's like, all right, so it's like my garage band, I don't really need to have, a roadie to move my stuff. Sure. Dad in the garage can do it, right? Yeah. But there is a point where, things like your trademark and things about how people are using your name in conferences and how people are talking about you to raise money, that you really need someone who can help handle that. And so we have legal services, for one, just like helping you get a trademark, helping you take money from a big organization like Microsoft. For example, Microsoft was one of our first corporate donors, and they gave us $100,000, which really helped a lot of the Jupyter work early on. And so it's very hard for an individual to go to a corporation and say, hey, I've got this great project, can you give me money? The other side of it's hard is the case of Jupyter, right, where you're spread around 4 or 5 universities, sometimes in two continents, maybe 3. Actually getting the money to the right people is difficult. So if you give money to like maybe there's 4 or 5 people who have created this, but who takes it? If it's a university, then there's certain overheads on the university, and the university expects scientific achievements out of that. And that's totally reasonable because they are focused on those scientific achievements. And we said, well, let's have a different entities that can be focused on the project getting money and the project itself determining how that money gets spent. Rather than, I think a lot of university money would go to individuals who then would contribute to the project, but then who really owned the code, why did it go back and forth? And so that legal service and then bleeds into the fiscal services. And then finally, like, I think the reason a lot of people come to us is around that fiscal side is like, hey, we would like to raise money. We would like to do it at an institutional level instead of like an individual level. Because there's a lot of like places that get individual money, like Patreon, Get Tip, and things like that. But to really hire developers and that maintain, you need to get a sustaining corporate donation or granting institutional sponsor. And so we said, like, well, let's just build something that can handle that. But we also know we need to sustain the organization. So we actually sustain the organization itself mostly from conferences like this.
I see.
And money that comes through, like we pay our staff, but then everything that goes over comes to projects. And for example, I think we have we did a grant kind of series last January and had about 30 different people come in, and we went through and actually deployed out, I think, about $15,000 worth of capital just on random projects for folks. Like, give us your project, let us know what we can do in a small way. But then if somebody says, well, I really need a developer, then we can help work with them develop. So one thing you have to do, you have to develop a roadmap. You have to develop like things that the public can give money to that's not just giving you money for the money's sake. And so help you develop that, help you to have some governance, like what happens when certain companies give more money than other companies, who decides what happens there. You really need to have a leadership committee, so we help you form a leadership committee, make sure it's an objective leadership committee, do that sort of thing. But there's also like maintenance, right? Like helping encourage diversity in our ecosystem. And so we have a lot of events. We have a summit where we bring people in and talk about like, all right, so how do you maintain a diversity? How do you maintain, don't burn out your developers? How does like you keep interest? And a lot of those pieces are cross-cutting. So we have some cross-cutting projects that are programs that all the projects like to come in and understand and do better with.
And that's nice because, like, let's just say I'm just sitting there and I coded up some Python thing that's really good, but needs to evolve and you help me with all of the business aspects of the stuff,
right.
Whereas I'm just literally just writing the code that I like to write. Is that a fair assessment?
Yeah, it's not going to be that you can only write code if you can work with us. Yeah. So what we'll do is we'll find 3 to 5 other leadership. And that's kind of one of our rules. Like if you can't find 3 to 5 people who are going to be leaders of your community, you're not big enough to really need an entity because like you're just kind of pretty small at that point. And so at that point, it gets shared between some people, and there's some basic procedures and those procedures come from like just laws around how nonprofits work and taking money. And so we're trying to be as light as possible. We have, like, we don't, for example, licensing is one thing that always comes up. And like, yeah, we'll help you figure out some licensing things, but we're not going to impose a license on you. We're just here to help the scientific community because scientists need software, and the universities and corporations can come together to help software exist. Sure. But you need some place to help coordinate that.
Let's talk about some specific projects that or some communities that you help engage in this manner. How did it start, and what does it look like now that they're fully engaged? So that if someone does they say, hey, that's me. We're building this thing. We have 20 people that are actively doing this. Right. How can we get involved? What does it look like when they got involved previous projects?
Yeah. So for example, NumPy is one that just got a major grant from the Moore Foundation and Sloan Foundation as well. And so effectively, they have it's an older project. I think they've been around since 99 or 98 or something. So, but they haven't had like a coordination around who's contributing and whatnot. And so first off, it's just kind of they were actually not one of our first projects, even though num focus, like part of it was like numerical, but part of it was like NumPy, because like a lot of the NumPy developers are interested. Yeah. But they weren't one of our first projects just because there was a lot of different opinions on who should be leading things. It was like, okay, fine, once you work that out, we'll help you. And so then, like, once they had a leadership committee kind of together, they came to us and said, can we actually raise this money? And then once they got the money, like once they came to us, like the awareness of that there's really only 5 or 6 actual contributors, but this is a project that affects thousands of people.
No, a lot of people.
And so you thousands of developers. I think there's 2 million downloads through the different different distributions a year. And so it's like, well, maybe this is a critical thing. And so I think Ford Foundation put out a big report about the bridges of sustaining open source. And Sloan Foundation and the Moore Foundation kind of saw these things and were like, hey, that's a really important thing for scientists, and we're all about helping scientists like actually succeed, so we better help you. So helping increase their visibility, and then pairing them up with the leaders of the community. Another project that's I think is really interesting, but still like much younger, is a project called Interact, which was like without the I, so just interact. And they're taking it as like, look, we need to help scientists be able to use our tools better. I mean, it's always a constant fight of, like, you think about the Jupyter Notebook, you got to set up, you got to learn the command line, you got to learn how to fire up this piece of software, which is actually pretty complex under the hood. And when it fails in ways, you got to read a console log and whatnot. So like, but we can teach people how to use files and how to open files and how to attach them to your emails. Why can't we do that with Jupyter Notebooks? And so they've basically built out systems using all the Jupyter protocols and and all the standards they've pushed that we've helped them like kind of outline, and by the governance like have a way to evolve those. But by having a governance platform, now they have a new project that's focused completely on computer literacy that uses all their things, but is confident that will evolve in a quality way, as opposed to a lot of open source projects. It's just kind of like, when it's just your side gig, break an API, no one cares.
Like if someone were to break a NumPy API, the world round would like hear the shots fired, right?
Oh yeah.
And so tell me about like, for example, like one of the things that I always worry about is when I'm using software that I like and that works really well, and I got it for free somehow, I always worry like, where will this be next week?
Right.
Like the question I always have is, how are these developers getting paid? Because they have to live somewhere, they have to eat. Is that the kind of thing that you're helping with sustainability? And how do you do that?
Sometimes it literally is hiring people, and like we have a staff. Largely, one of the pieces is like we've hired a lot of contractors to work on these projects. We'll get a grant in, and we'll help manage those contractors. We don't have like we don't have on-staff developers yet, but maybe in the future. But the one piece is, if you want to be able to get money at that level, you first have to have a home, you have to have an entity, and then we can help you get grants and bring things in. We do campaigns. Like if you're an individual, you want to just contribute, you can go to our webpage, you can contribute to any one of those. Those are generally like monies to get people to like conferences, which is really important. If you want to move your project forward, like that's probably the hardest thing in open source is getting that release out. And you think about most engineer teams, they like get together in a room and release. Well, if your project's across a continent, you got to find a place to get together and release. Sure. And that's where like conferences like this matter. And so we've done that a lot, of helping people get to the right spot, and so they can communicate well. And so it helps on all fronts. But the biggest thing that people can do is come to our conferences, talk to us, and if your employer is using our software, I think one of the like Civis here, like one of our members is like moved there. He's like, well, why aren't you a gold sponsor? And like all of a sudden, boom, like we're giving more money to some of the projects they use. So
why don't we just spend the last 5 minutes? We have about 5 minutes. Why don't we spend this time talking about some of the projects you support, and then let's talk about the conferences that you put on and how that helps the entire thing. So let's start with some of the projects.
Yeah, so we started kind of NumPy, SciPy is kind of the base. We support Pandas, which Pandas is the kind of the layer of, it's the data frame, which kind of came from R, but it's like the data wrangling ninja needs to use, right? And it takes a little bit to learn it, right? But once you get it, like that's the thing that really enables people to ad hoc queries very quickly. Jupyter Notebook obviously has been talked about quite a bit. We also have a lot of different languages like Julia, Stan. We actually have supported R in different ways. We have the R OpenSci project to work with, and so kind of all over the place there. My particular favorite is SymPy, which is a symbolic Python library.
That's cool.
That I helped contribute a long time ago, back when I could do those things. So like all sorts of symbolic libraries. I think some of the interesting is we've started to see more like traditional modeling, like finite element and physical modeling coming in. So we have the Phoenix project working with us, which is a project that they're doing all sorts of health and ocean modeling and some like more physical modeling. So a lot of really cool things.
I mean, it sounds like you're focused on numerical type stuff, which is why I guess your name is NumFocus.
Yeah. And I mean, for us, it doesn't even have to be like Num might be, SciFocus might be a little bit better because it's really like software that is there to support science and isn't really being supported by other organizations. Like for the Apache Foundation is an awesome foundation supporting the internet technologies and big data technologies, but they don't have a specific mission around scientific software.
I see.
And so that's kind of where we said we need to step in and help the scientist software, because software has eaten the world. It's eaten the scientific world. If we don't have good software for our scientists, we're not going to get all the advancements they bring to society. And that's what really drives me, is to make sure that the scientific tools of my colleagues, because I started out in the scientific world, and I'd like them to continue to have the best tools possible.
So just to finish up, we have probably about 2 to 3 minutes.
Yep.
Let's talk about the conferences that you put on, like this one.
Right.
Why don't you talk about that and how it actually helps the goals of the foundation?
Yeah, so this is PyData, and it's our Python-centric conference. And this one is kind of our first kind of conference and our first endeavor in this. And we actually started in a room with Guido where we sat down and we was like, hey, Guido, there's all these things that the Python ecosystem's not doing for us. And he says, well, go do it yourself. And so we're like, well, okay, how do we do that? And well, let's just get together and start talking about it every year. And it's grown to be, I think we have 12 different conferences in this year. We have in our PyData ecosystems 30,000 different individuals who've come to conferences and whatnot. And people have seen that success of like, it's a very natural work for the developers, have the projects, encourage projects, give diversity scholars to come in. There's several other projects that say, hey, can we repeat that? So now we have JuliaCon, which just happened a week or two ago.
Awesome.
And they're doing the same thing where they're building up their grassroots. They're able to engage in corporate sponsorships and actually meet the people who are using things in the corporate world as long, and the industrial world or the academic world and government and whatnot. And so having that mixing really helps people understand who's using what and what features they should be working on and how they should implement things better. And so it all comes down to that community and communication. Now, all the proceeds we get out of these conferences, because they're not free, because what we do is pay as low as we can.
You got to pay for stuff, yeah.
And all that goes back to the running of the nonprofit and giving back to projects. Mm-hmm. And so, out of one of these things, I think we'll pull our staff fees, but we'll also pull tens of thousands of dollars just going to helping people go to the next conference, or helping them do their release, or helping them maybe get those developers if they can swing them for small things and whatnot, right? And so it all kind of feeds into itself. We need the community in order to talk. Right. That makes the software better. We need the money to pay people, and so that back and forth. And now we have like Phoenix is leading its own conferences. JupyterCon is coming up in August. It's going to be it's our first large partnership with O'Reilly. So it's a little bit.
Go around. Thank you. Go ahead. Sorry.
So JupyterCon's kind of a bigger endeavor in New York, and it's like we'll see how that works. And so we've been able to done partnerships with different organizations. So it's just been really great. Kind of like the PyDatas are great because we often end up in a place like this, Microsoft or Bloomberg or Facebook, and see how the companies are using them and the excitement the companies can bring to.
Well, this is awesome. I think you're doing good work, man. Awesome. I've used this stuff for a long time. I'm very glad that now there's a foundation that's supporting this kind of work. Thanks so much for what you're doing. Thanks so much for the conference. And now we're going to take you back to some more sessions that are going to start probably in about 10 seconds. So we're going to cut over there right now.